Hi and welcome to DBWatch. Today I will give an introduction to a new feature in DBWatch 12.4.8, Global Views. This is a view or dashboard that focuses on giving the DBA an overview of a specific metric across the entire database instance estate. This video focuses on the first group of global views that are focused on performance metrics. And this is my test environment. It's set up as a small service provider with 7 customers with a DBWatch server located on premise at each customer location. The global views are located in the monitoring part of DBWatch and next to the instance global view. Since DBWatch 12, we have had support for custom global views that you create yourself, but new now is that we also ship a set of views that cover insight that we feel most customers would enjoy. The global views try to highlight information that we already collect when we monitor database instance metrics in a way that gives a global perspective of your database estate. And in this video, I'll focus on the global views under the performance metrics. This is part of a series of videos that will cover other focus areas such as capacity and maintenance, and also videos that will cover the process of using the views itself for quickly identifying problems across your database estate and drilling down into individual instances. The global views that focus on performance is located under the tab called Performance. Here we have weights, file I/O, DML test, logical reads, and page life expectancy. In future releases, there could be other views added on as well. When we look at the title line for the weights view, which is the first view under the performance section, we can see that it says weight statistics, Oracle and SQL Server platforms. So as of version 12.4.8, only Oracle and SQL Server are supported in this view, as they have comparable statistics for this metric. But we expect that more database platforms will be added later if they provide this type of metric. You will see that I go through the views that some are only for one platform, such as SQL Server, but there are also some that are multiple platforms. The global views for weight statistics has several fields. First, we have the given name of the database instance, and then next we have the database platform and version. We also list out the number of logical CPUs that are reported by the database instance. Then we have the weights total bar. This is the current weights for the database instance relative to the limit of the database instance. By default, warning threshold of 85% and alarm threshold for 95% of the limit of the database instance. In weights, it's possible to have weights that are more than 100% of the capacity or the limit of the server. Next field, we have the type of weight that has the highest wait time, and how many percent this type of weight has, where 100% is the weight limit of the database instance. In the same fashion, we list the second and third weight types sorted by wait time. The weights average working hours field, it shows how much weights this database instance has on average in the period defined as working hours, which is between 8 a.m. in the morning and 4 p.m. in the afternoon, based on the time zone of the database instance. So it will indicate the type of weights load you will normally expect on this database instance during work hours. We also have the ignored types field, which will list any weights type that is configured to be ignored by the task collecting data. And the last field, called DBWatch server, we have the given name of the DBWatch server, which in this setups corresponds to the customers that we are monitoring. When you right-click on a database instance, you get a menu for the task, the underlying task collecting this data, where you'll have the possibility to run the built-in report on this metric by selecting details, or maybe configuring monitor to ignore certain weights type. The next view we have is file IO, which focus on disk latency or write latency. In the same view, way as weights view and most other views we make, the first two fields are a database instance given name and the database platform type with version. And the last field is DBWatch server given name. A given name is a name you have chosen when you add the instance to DBWatch server, or the DBWatch server is added to DBWatch monitor. To maintain the cross-database platform support, we have named the field space, where you on SQL Server would have like the name of the database, and on Oracle you would have the table space name. But it's to have a comparable field name, we called it space. And for each space, we have the name of the database or table space, the disk the data file is located on, the current write latency, and the current amount of writes in kilobytes per second. We do the same with the three top spaces, ordered by the amount of writes they have. We also show the average latency during working hours, and the ignored spaces, and the max write latency for any space on the database instance. There could be a space that has very little writes, but have a longer latency than the top spaces. And to dig into that, you have to run the report by right-clicking on the instance and clicking details. We won't go into that detail right now, but that's how you get the details on other spaces on that database instance that might have a high latency. The next view we have is the DML Test view. DBWatch has a task to test the DML performance of a database instance. This runs a series of performance tests on the instance with insert, selects, updates, delete on a set of data. And the default setting is to run the test on 5, 10, 20, 40, 80, and 160,000 records, triggered internally in the database engine so that network latency does not come into play. So in the same as the other views, we have the database given instance given name, and the database platform with version, and the SQL Server given name. But this view also lists the host the database instance is running on. Then we show the number of logical CPUs, and we have something called a check field. This is the performance metric to calculate the speed of the system across database platforms. So how a database platform operates will affect the DML performance statistics. Some platforms, such as Oracle, will have a very fast select, but suffer on insert, update, delete versus SQL Server due to how the database platform writes and reads data. To negate this effect, we test different database platforms on identical hardware and generate an algorithm to compare the relative hardware performance of the underlying system on database platforms with different characteristics. So that is what the check field is. So the bar will turn orange between 8 and 9 and red above 9. To compare to this number to a real system, 3.5 would be like the performance of a 5-year-old laptop. Similar to the one we used in the Azure article. You can Google that, Azure performance, and you can see this. It's a similar type of test on that. And 10 is about the performance if you put a Windows 2012 server with a SQL Server on a single 2 GHz core. So that's a very, very slow system. It's close to the limit of what you can connect to and work normally on. The DML performance bar is the average time for insert, update, select, delete for 1,000 records. So the DML millisecond shows the average time for this on 1,000 records. And next we show the time divided into the time used for select, update, insert and delete. And the next field, it shows the number of tests run on this system. The deviation percent field shows the relative difference between the time taken for 1,000 rows and how that differ between different tests. And if you have a high deviation percent, you can have an unstable, could be indicating an unstable performance on this system. The DML test has a section in the management for each instance as well, and there is a good report that can help you understand how your system is performing. So the next tab is logical reads. This view focuses on the number of logical reads and the hit ratio of the database instance, how the logical reads are spread across 3 different periods during a 24-hour cycle. So we define working hours between 8 a.m. and 4 p.m., evening hours between 4 p.m. and 12 p.m. midnight, night hours between 12 p.m. midnight and 8 a.m. in the morning. So we can see that this database instance on top has a lot of logical reads. But a very good hit ratio. Most reads during the day, but also quite a high load during evening and night hours. The last view we will look at today is the page life expectancy view. This metric is a SQL Server specific and focuses on the life of pages in the data cache. Here we show the current number of logical reads, the current page life expectancy of the data put into the data cache. We can also see how the pages are spread across different periods, less than 10 minutes, 10 to 40 minutes, 20 minutes to 2 hours, 2 hours to 8 hours, 8 hours to 24 hours, and more than 24 hours. A low page life expectancy could be the result of a too small data cache on this database instance. All the views we have covered today will have individual reports on the status of this metric on that specific database instance. And this is the first step to identify and dive into the problems. And the actual process of doing so will be covered in other videos. And that is all for this video. Look out for other great videos that focus on other areas of DBWatch, and thank you for watching.